Okay, welcome to your second video on fractions. Look how cute this little guy is. Okay, what are we going to be looking at with this one? We are going to be looking at adding, subtracting, multiplying and dividing fractions using some of the prior knowledge that we've already got over the last few weeks. Okay, let's have a look at adding or subtracting fractions. Now, the first thing you need to remember with adding or subtracting fractions is your denominators must be equivalent. So I've got a denominator here on my left of 17 and a denominator of my right on the 17. They are the same or equivalent, which means all I have to do is add my numerators. So my denominators are equivalent, so they are 17, and I simply add 3 plus 6, which is 9. My answer becomes 9 on 17. That's how to add two fractions. The last step before I finish is I need to see if I can simplify this guy by finding the highest common factor, or by finding to see if there is a common factor to start with. Is there any whole number that goes evenly into both 9 and 17? My answer is no. So I leave it as 9 over 17. Quick revision, my denominators are equivalent, which means I can simply add. Very straightforward. Guys, this should again be a revision from last year. Okay, let's have a look at our second example here. Got a bit of a problem. I'm trying to add a half plus 3/5. My denominators are not equivalent. So before I begin anything, I must make them equivalent. I must find a number that goes in that is a multiple of both 2 and 5. What? Mr. Corsi already told you how to find lowest common multiples. Isn't she awesome? So, this is how we do it. We're trying to find the lowest common multiple of 2 and 5. That can then be my common denominator, and I can manipulate the fractions in order to work out the answer. So I'm going to find the lowest common multiples of 2 and 5. So I'll jot down 2. Let's do the multiples of 2. 2, 4, 6, 8, 10. That'll do for the moment. I start with 5, and then if I haven't found a common one amongst them, I can keep on going. And we'll go 5, 10, 15, 20, 25. Lo and behold, I have a common multiple. When I look at my multiples of 2, I've got 10. When I look at my multiples of 5, I also have 10. So, my common denominator that I'm going to have here, guys, is 10. Again, this should be a revision. Okay, so my common denominator is going to be 10. Now, what multiple of 2 is 10? What have I had to do to 2 to make it into 10? I've had to multiply it by 5. What I do to the bottom, I do to the top. What I do to my denominator, I do the same thing to my numerator. What I do to the top, I do to the bottom. What I do to the bottom, I do to the top. Just in case you missed the memo, what I do to the bottom, I do to the top. Now, I know I sound like I'm being really annoying, guys, but I really want to stress that point. Whatever you do to the bottom of a fraction, you must do the identical to the top. So, other fraction. What multiple of 5 is 10? And the answer is 2. So I've multiplied by 5 by 2 to get 10. So it then becomes 1 multiplied by 5 is 5. 3 multiplied by 2 is 6. Now all we have here, 5 on 10 plus 6 on 10, is another way of saying a half plus 3/5. It's just a different way of writing it. However, now that I have a common denominator, I can simply perform my operation by adding my numerators. So my answer becomes 11 on 10. And as with the last example, I look at this to see is that the most simple way I can write it. And I've noticed something a little bit interesting. I've noticed that my numerator, or this guy on the top, is larger than my denominator. When my numerator is larger than my denominator, it's called an improper fraction. Okay? So, converting improper fractions, this therefore becomes 10 goes into 11 once with a remainder of 1 on 10. If you're confused about this, converting between improper and mixed and improper, go back and have a look at the other tutorial. Okay? Cool. Let's look at the next example. Let's get rid of some of this stuff. Beautiful. Perfect. Now I've done 2 addition ones. I think I'm going to do a subtraction one. Okay. What do we got here? 3 2/5 minus 2 3/4. Okay, little bit of a problemo here. 1, they're mixed numerals, and 2, it's all over the shop. So, with mixed numerals, before I can perform any addition or subtraction or even multiplication or division, as you'll see, I have to convert them to an improper fraction. So, 5 multiplied by 3 is 15, plus 2 becomes 17 on 5, minus 4 multiplied by 2 is 8, plus 3 becomes 11 on 4. Okay, so that's my fraction. Again, I'm trying to find a lowest common denominator. So I do it by writing out my common denominators. So 5, 10, 15, 20, 25, 4 ones are 4, 2's are 8, 3's are 12, 4 4's are 16, 4 5's are 20. There we go. I knew 20 off the top of my head. The more you practice this, the more you will. 20 common, 20 common. Okay, what have I had to do to 5 to get to 20? I've multiplied it by 4. What I do to the bottom, I do to the top. What I do to the bottom, I do to the top. And 4 I have multiplied by 5. So, 17 times 4. Do not get out your calculators, okay? You can do this in your head. 17 is another way of saying 10 and 7. 10 multiplied by 4, 40. 7 multiplied by 4, 28. 40 plus 28 becomes 68. Oops, sorry, my common denominators. I'll draw them down the bottom. 20, okay. 11 multiplied by 5, 55. Okay. 68, subtract 55. My answer becomes, oops, sorry, I've run out of room here, guys. We'll just go up the top here. My answer becomes 13 on 20. Last thing I do for myself is I ask myself, is there a factor that goes into either of these? So is there a factor that goes into 13 or 20 without any remainder? My answer is no. So my answer becomes 13 on 20. Okay, multiplying. Multiplying is really easy actually, and it's quite fun. It's pretty straightforward. So, 3 over 4 multiplied by 4 over 1. Super easy, super easy. All I need to do is, I simply multiply my numerators and multiply my denominators. So, this guy multiplied by this guy multiplied by that guy. Really straightforward, guys. Okay, so this becomes 3 multiplied by 1 is 3, 4 multiplied by 2 is 8, my answer is 3 over 8. What do I need to check? I need to check if I can simplify. How do I check if I can simplify? To see if there is a common factor, particularly the highest common factor. There is no whole number that goes evenly into both 3 and 8, so that's my answer. Super. What else have I got here? Okay, ooh, what else have I got? Okay, let's try this guy. 3 on 7 multiplied by 7 on 9. Now, I could do the same thing. I could go through and multiply my numerators and multiply my denominators and then simplify at the end. But I'm going to teach you a little trick that you guys can do. You can actually simplify as you go. So, we simplify by the cross method. So, I'll show you what I mean by that. I mean that when I look at this, instead of having to simplify at the end, I can simplify as I go. So 3 and 9, do they have, what's the highest common factor, or the highest common same number, same whole number that goes into both 3 and 9 without a remainder? The answer? 3. 3 goes into 3 once, 3 goes into 9 3 times. Now, 7 and 7, it's pretty obvious their highest common factor is 7. 7 goes into 7 once, 7 goes into 7 once. 1 multiplied by 1 is 1. 1 multiplied by 3 is 3. See, I've already got my simplified thing there. So I didn't have to wait to get my answer. So if I didn't simplify, this is what it would have looked like. I didn't simplify, let's rub this out and I'll show you what it would have looked like. Okay, so it would have been 21 on, because that's 3 multiplied by 7 on 7 nines are, 7 nines are 63. then I would have had 21 on 63, and I'd say, oh gosh, what's the highest common factor of 21 and 63? And after a while, I would have worked it out that it was 21. 21 goes into 21 once and goes into 63 3 times. Okay? So technically, I could have done that without simplifying, but see how much easier that answer was to come to than this would have been. Okay? So that's multiplying, but simplifying on the fly as we do it. Okay, let's have a look at another example. What can we do here? Okay, let's have a look at multiplying mixed numerals. Okay, first little problemo that we have here is that these guys are mixed numerals, not improper fractions. So before I can really do anything, I'm going to change them into improper fractions. Okay, so 2 multiplied by 3 is 6. My new number of 6, I add 1, becomes 7 on 2, multiplied by 5 multiplied by 1 is 5, plus 3 is 8 on 5. Now, if you had a problem with what I just did there with converting, go back and have a look at the other tutorial, which is on converting mixed to improper and improper to mixed, okay? So next thing I do now that I've learnt this new fun simplifying on the fly thing is to see if these two numbers can relate to each other. So if 7 can relate to 5, if it has a highest common factor, or in fact any common factor at all. 2 and 3, no, they don't. So 7 3s are 21, 2 5s are 10. So my answer becomes 21 on 10. Little problem with it at the moment. 21 on 10 is an improper fraction. My question got asked to me as a mixed numeral. So if my question gets asked as a mixed numeral, it tends to be a lot more sophisticated if I give my answer as a mixed numeral. So again, let's go the reverse way than we just did. We'll change an improper fraction back to a mixed numeral. 10 goes into 20 how many times? 2, with a remainder of 1, and I put my denominator back. So it becomes 2 and a tenth. Okay? If I get my question given as a mixed numeral, I am expecting my answer as a mixed numeral, whether or not I've had to change it as part of my working out. Cool. Let's look at one more example just to be safe. Again, we'll try it here. So 5 multiplied by 4 is 20. 23 this becomes on 4. 5 multiplied by 2 is 10. 10 plus 2 is 12 on 5. Now, remembering that simplifying on the fly thing that I've just learned, let's see if I can do anything here. 23, I'll just put my multiplication. 23, no relationship or no common factors there. 4 and 12, however, do. My common factor with these is 4. 4 goes into 4 once and into 12 3 times, okay? So this is going to make my life a little bit easier. 23 multiplied by 3. Do not get your calculators out. 20 multiplied by 3 is 60. 3 multiplied by 3 is 9. So that becomes 69 on 5. Okay, my answer is 69 on 5. I got my question asked as a mixed numeral. I give my answer as a mixed numeral. How many times does 5 go into 60? Well, I know 5 12s are 60, which must mean add another 5 will be 13 to get me 65. So 5 goes into 65 with a remainder of 4 over 5. So 5 times 13 is 65. I've got a remainder of 4, and I keep my denominator the same by 5. Okay, excellent. That's that done. Supercalifragilistic. What else can I do? I can also divide, which is lots of fun. Division. Let's have a look here. Now, a third divided by a half. All I need to do here when I'm dividing is to flip my second denominator, my second fraction. I need to flip the numerator and the denominator. So it becomes a third multiplied by 2 over 1. What I have done there is I have flipped my second's fractions, numerator and denominator, and now it simply becomes a multiplication. 1 multiplied by 2 is 2. 3 multiplied by 1 is 3. The answer is 2/3. Okay? All you need to remember with dividing is flip the numerator and the denominator of the second fraction and simply perform a multiplication step. That's it. Let's have a look at another example. Okie dokie. So we've got 12 on 15 divided by 4 on 3. Okay, so I know I need to flip it. So I know another way of saying that, or an equivalent way of writing that, would be 12 over 15 multiplied by, I flip my second fraction's numerator and denominator, and it becomes 3 on 4. Now, why do I do that? I've got a division, okay, and I'm trying to convert it into a multiplication so I can do something with it. I'm doing the opposite. Therefore, my second fraction needs to also do the opposite. So that tends to be a good way of remembering it. If I want to convert it into the opposite, I must do the opposite to my second fraction. Right, excellent. So, before I begin, I could work this out, but I learnt a really handy trick in the multiplication and division. I'm just going to write this a bit better. In the multiplication and the division one, which was I should probably first check to see if my cross fractions can be simplified. So, they can. Lo and behold. Oops, let's rub that out. Let's fix that up. Excellent. So, 12 is related to 4, and they have a common factor, which is 4. 4 goes into 4 once, 4 goes into 12 3 times. So what I've done there is I've simplified these two parts of the number sentence because they have a relationship. I can also go ahead and simplify these two parts because they also have a relationship. Their highest common factor is 3. 3 goes into 3 once, 3 goes into 15 5 times. Now, I knew those off the top of my head. You might need to write factors for your numbers, okay? So if you need to write factors, a factor list out, you could have written 3, 15, and gone 1, 3. They're my factors. 1, 3, 5, 15. And then worked out that 3 was a common factor between both of them, okay? Once you get used to working out common factors, in order to find the highest, it becomes a lot more simple. So if you found you couldn't just do that off by heart, you probably need a little bit more practice. Then 3 multiplied by 1 is 3, 5 multiplied by 1 is 5. Pretty straightforward. 3/5. Last thing I do, I check to see if it can be simplified by finding a highest common factor. There is none, so I can't. Pretty straightforward, guys. Okay, let's have a look at another example. Lo and behold, we have the same problem here as we have with our multiplication. It's cool, 1 6/10 divided by 1 3/5, but I can't actually do anything with it at the moment because it is a mixed numeral. In order to do anything, I must convert it to an improper fraction. 10 multiplied by 1 is 10, plus 6 is 16 on 10, divided by 5 multiplied by 1 is 5, plus 3 is 8 on 15. If you did not understand that, you must go back and have a look at the tutorial converting improper to mixed and vice versa. So now that I've converted, what do I need to do? So now I've got something to work with. I know my first step is flipping these guys because I'm wanting to do the opposite. I want to convert it into multiplication so I know what to do with it. So I must do, that's the opposite operation, so I must do the opposite here and flip my numerator and denominator. Now we've learnt that as we go, the easiest way to come to an answer is to check if I can cross simplify. Check to see if this has any relationship to this number or this has any relationship to that number. 6 and 8 have a common factor. Their common factor is 8. 8 goes into 8 once, goes into 16 twice. 10 and 15 have a common factor. The common factor is 5. 5 goes into 10 twice, goes into 15 3 times. Okay, now I've run out of room, so Mr. Corsi is going to just go up back here to, where can she go? She's just going to go up here. She's going to go above it. Sorry, guys. So, 2 multiplied by 3 is 6. 2 multiplied by 1 is 2. So, my answer becomes 6 on 2. Now, I got given 6 on 2, or my question, Let me just write that out again. I got given my question as a mixed numeral. Therefore, my answer must be a mixed numeral. How many times does 2 go into 6? The answer is 3 times. There is no remainder. No remainder whatsoever. So the answer that I'm giving is 3. Pretty straightforward, guys. The answer is 3. I get given it as a mixed numeral. I give my answer as a numeral rather than a fraction. Last example, last but not least, because we have been here for a while. 3.5 divided by 1 3/5. So first thing I know I need to do is I need to convert it. 2 times 3 is 6 plus 1 is 7 on 2. I'm going a bit quick now, guys, because I don't want to waste your time because you should be used to these things. Divided by 5 multiplied by 1 is 5 plus 3 is 8 on 5. Next thing I do is I flip it over. So I say 7 over 2, opposite operation, I opposite these guys. So become 5 over 8. Check to see if I can cross multiply. Nope, they have no relationships. So 7 5s are 35. And 2 multiplied by 8 is 16. Okay, I get my answer as a mixed numeral here. I must provide my final answer as a mixed numeral. 16 goes into 35 how many times? Do not get your calculator out. 10 multiplied by 2 is 20. 6 multiplied by 2 is 12. So 20 plus 12 is 32. That is 2 times with the remainder of 3 over 16. Can I simplify 3 over 16? No, I cannot. Therefore, that is my answer. And that's it, guys. That is the very lengthy process of both adding, subtracting, multiplying, and dividing fractions.